All right, so this time we're working with the distance and midpoint formulas. And you look here, let's just read through this paragraph. Sometimes it's necessary to study line segments on the coordinate plane. That's what this guy is here, okay? A line segment, or part of a line, contains two endpoints. So let me just give you a sample one. Let's add here and here. Why not? And we got to connect those two. So there's your line segment, and it has its two endpoints. The coordinates of these endpoints can help us find the length and the midpoint. So anytime you have coordinates, right, like you have an x value and you have a y value. Those are the coordinates, x and y. All right. Let's see. The coordinates of these endpoints can help us find the length. So that's going to be how long it is. And the midpoint, right? It's going to be somewhere here in the middle somewhere. All right. Or the point that's halfway in between the two endpoints of the line segment. We can calculate the length of the line segment by using the distance formula. I'm going to give it to you right here. You can calculate the midpoint of the line segment by using the midpoint formula. That's down here. Now, if you look at this distance formula, you see it's got some stuff getting added. It's got some squares. Hopefully, this is reminding you of what you just finished doing, which is the Pythagorean Theorem. Look, if you want to find out this distance, you can make yourself a little right triangle here. All right, let me make these red because I have the power to make them red. Okay, so if you count the, you want to know this distance? Well, you can just think about it as here's A, here's B, and here's C, and you just worked on using the Pythagorean theorem to find the value of C if you have A and B. Well, to find A, here's the first point. Here's the second point. So I'm just going to call this x1, y1. I'm going to call this x2, y2. And you see what they're doing? They're subtracting x2 minus y1. Well, here's x2. Here's the value for x2 right here. All right, that's x2. Here's the value for x1. When you subtract x2 from x1, you're finding the length of side A. So this is really telling you how to find side A. When you do y2 minus y1, here's y2, here's y1. When you subtract them, you're going to find the length of side B, right? y1 ends up, here's y2 minus y1. So you find the length of side B. Now remember, if I said that c squared equals a squared plus b squared, there's a Pythagorean theorem, just backwards. A squared plus b squared equals c squared. If I do the square root to get rid of that squared, then c equals a squared plus b squared, and voila, that's essentially what the distance formula is saying. So just a heads up, it's not coming out of nowhere. That's the formula. Now, you don't necessarily need to know where it came from in order to know how to use it. All right, so if you look down at this example here that they gave us, we're trying to find the distance between 2, 3, and 6, 8. All right, let's see if we can make this fit on the graph. Whoops. Get rid of these lines. All right, so here's 2, 3. So what I'm going to do, I'm going to stretch this out just a little bit. So 2, 3 would be like, right about here. 6, 8 is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So there are my 2 points. And if you think about it, you would have a segment that went something like this. So we need to find the length. Now, since this is 2, 3, all right, here's 2, 3, here's 6, 8. So that means x1 is like 2. Let me zoom in here a little bit. Zoom. Let's go. All right, so x1, y1, x2, y2. So y2, if I want to know, let's see, the first part of the formula says x2 minus x1. That would be 6 minus 2. So that's what we have here. Let me go back to zoom out. All right. There we go. So there's the 6 minus the 2. Y2 minus y1 is 8 minus 3. And then you're just doing a calculation. 6 minus 2 is 4. You square it, you get 16. 8 minus 3 is 5. You square it, you get 25. Add them together, you get 41. The square root of 41 is about 6.4. So this distance here is about 6.4 units. All right. Now the next thing they said was you also had to find the midpoint. And look what the midpoint formula is. They're doing x1 plus x2 dividing by 2. You see how that's really just finding the average between these 2 points? Remember how you find the average? You add up things and you divide by how many you got? Well, if you add up 2 and 6, and then you divide by, since there was just 2 numbers, you divide by 2, that's really going to tell you what's halfway between 2 and 6. Now, you don't need to do all that. You can tell halfway between 2 and 6 is 4 with using just a little bit of common sense. So when you do this formula, it shouldn't come as a surprise that, okay, there's, oh, you know, they switched up the numbers here so that, you know what I just realized? Let's use the points in their example instead. But you could find the midpoint of these points. But let me just, to save a little bit of time, let me use their example. So for this one, I'm going to show you what happens if we have the points. Let's see here. 5, 1. Here's 5, 1. And negative 1, 5. All right? And we want to know the midpoint. Well, you can tell it's going to be like somewhere in here, right? Well, if we, and again, you can connect that segment to see that. All right. Well, here's the point, negative 1, 5. And here's the point, 5, 1. So again, here's your x1. Here's your x1, y1. Here's your x2, y2. So we want to go halfway between the x's, negative 1 to 5. Well, to do that, x1, oh, they actually switched them around. Oh, man. Let's just switch these around. It really doesn't matter which point you call which, but let's just be consistent so there's no confusion. It would have worked just fine if you did it the other way. So x1 they're calling 5, x2 they're calling negative 1, y1 they're calling negative 1. What is going on? Why am I losing my mind? Okay, I was losing my mind. This didn't print out well. Y1 equals 1. It's not negative 1. Okay, so y1 is your 1, and then y. What is happening here? Y2 should be 5. They made a couple typos here. That's impressive. That should be y2 equals 5. Okay, so you plug in your values here, and x1 plus x2, 5 plus negative 1 ends up giving you 4. 1 or y1 plus y2, there's 1 plus 5 is 6. Then we had to divide both of those by 2, so you end up with 2 and 3. So 2, 3, there it is, just like we predicted, is the midpoint. There it is. Now look, you don't need the graph to do these problems. You can just use the formula. If I were you guys, I would just label each one of these. I would call the first guy, here's x1, y1. Here's x2, y2. And then you can just plug and chug in the formula, right? So go ahead and try it. I'll meet you at the finish line. All right, hopefully you have, if you haven't already, pause the video, check to see what you can do with those 6 problems. And now that you have paused it, check to see how you did. So if you did it right, answer should look like that. I probably made a mistake in there somewhere, but I'm sure you'll let me know if I did. Here we go. Next page, same idea. You got to find the distance, you got to find the midpoint, but then there's one other thing. Hopefully you guys remember our favorite term, the slope. Just in case you didn't, there's a refresher how you find the slope, right? So let's see if you can tackle this chart. All right, so just in case you try the first 6, it should look, or the first 9, should look something like that. That'll get you on the right track. You can finish this up. Remember, you got to show all your work. Just having the answers is not enough. All right, catch you guys on the flip side.